Hey scholars, welcome back to chapter 1, where today we're looking at 1-3 and also 1-4, mainly focused on ecological footprints and how are ecological footprints really affecting the earth, what are they, and really what's the whole deal about them. Let's take a look at resources first. And most sources, well I shouldn't say most, some sources are renewable, ones that we most likely don't use, but they are renewable, directly available for use: solar, fresh air, wind, fresh surface water, fertile soil. Those that are not directly for use are more non-renewable, like petroleum, iron, and things like that. Underground water and crops, though, considered would be renewable resources. Always the perpetual resource, which is the solar energy. As long as it doesn't, blow up or anything like that, we're good to go. It's a renewable continuous energy source. There are renewable resources like forests, grassland, fresh air, fertile soil. And there's also those non-renewables, which you guys know of as like oil, coal, things like that. There's a couple more terms to know as the term sustainable yield. And this is the highest rate at which a renewable resource can be used indefinitely without reducing its available supply. So you have a forest of trees. You can only take so many in a given amount of time where they wouldn't be able to actually replenish that forest themselves. So if they have a really, really fast growth rate and reproductive rate, that's good. But if not, then that sustainable yield will be much lower. Environmental degradation is when that available supply actually does begin to shrink. And that's what we really want to avoid as far as maintaining natural capital. Here's a couple of degradations that we see most off of: water pollution, declining of ocean fisheries from overfishing, aquifer depletion, shrinking of forests. As you can see there, soil erosion, global warming, air pollution, all those things can cause degradation of natural resources and natural capital. So there are three types of property resources, and that's where we're going to look at property, and it can be over-exploiting share renewable resources can be dangerous, which as we know as the tragedy of the commons, which you're going to read about in just a second. But there are three types of property. There's private property, common property, and open access renewable resources that are open to all. And what I want you to do right now is take a second. You can go ahead and pause me for right now. I want you to open up to page 13 or go to page 13 on your virtual book and take a little read on what tragedy of the commons is. And I also want you to think about some solutions for that, for those situations. So go ahead and do that now. Go ahead and pause me right now. All right, welcome back. So hopefully you guys saw on page 13 the tragedy of the commons. It was a book that was written by a well-known author at the time, Garrett Hardin. 1915 to 2003, he died, and he really referred to as that shared common resource if overuse. And his slogan was, "If I do not use the resource, someone else will. That little bit that I use or pollute is not enough to matter. And anyway, it's a renewable resource." So basically, it's just saying that not knowing what everyone else is doing and kind of thinking, well, if I don't use it, somebody else will. That mentality will lead to the downfall of that resource. So hopefully you found some of the solutions, like private ownership, converting that open access resource to private ownership, having some distinct estimated sustainable yields that everyone knows about. Things like that might help deter from the tragedy of the commons. So that's what that one's all about. The non-renewable resource you guys know are most familiar with because what we use in most of today's society, which are coal and oil for energy resources. Metallic minerals like aluminum and copper to make aluminum soda cans and copper roofing. Non-metallic mineral resources like salt, sand, things like that are all non-renewable. Now, these two terms, reuse and recycle, get so often jumbled up and kind of flipped around and get exchanged for other. The word reuse is to literally not change the form or molecular compound of what is being done. So for instance, great example, the old milkman scenario, where I know this is way before your time, probably your grandparents' days, where they used to sit out glass jugs. The milkman would come, take those jugs, fill them with milk, bring them back with full milk. Then you would use that, consume it, then sit the glass jugs back on the porch. So you would reuse the same bottle over and over again. Also, like our typical Nalgene bottle, instead of using plastic water bottles that are just throw away or recycle, you can use one of those plastic Nalgene water bottles and keep refilling it over and over again. That would be an example of reuse. The recycle portion is literally where you break it down and then you turn it into either something else or a different form. You have to use some energy on it. So like you take your aluminum can, for example. Your aluminum can is then melted down back to that aluminum state, reformed into a can, put a different logo on it, and then therefore it's recycled. But it is changed. It has changed the form of it some way, and that's what we call recycling. Okay, so that is the difference between the two. I hope you remember that. Sometimes they ask you about that on the exam. So reuse is there's an example of the bottles, the old beer bottles. They actually return back, they refill them, they put a new label on them, but they don't change the shape of the bottle or anything like that. This is just interesting about natural resources and consumption. This is a family, I believe it's in Tibet, and all their belongings that they own compared to the typical American Texas or family from Tennessee or Texas, and all of their belongings. And you can see the difference between a society or a country that is very, very well off and prosperous, and you can see one from more of a impoverished nation. But you also to see what really things are valuable to them. And what really the cool thing about this picture is the things that are closest to the humans in this picture are of what is most valuable. So you can see obviously religious artifacts, possibly made out of precious metals, whereas the Bible in the Texas family, the cowboy hat, things like that, the dog and the fire hydrant, close to them. The ecological footprint. So let's take a look at this. An ecological footprint concept is really the amount of biological productive land and water would be needed to supply a people or a person of a particular country or area with the resources it needs to absorb and also recycle the waste and pollution and produce as a resource. So it's basically like how much land would it take to keep you an average or the person like you if everyone was like you in the world, and how much land would that take and how many earths would that take if everyone lived like you. So you can see that in the United States per capita, this is obviously the United States has one of the highest. We are one of the most wealthy nations in the world. As far as the per capita, it's 9.7 hectares per person compared to the next highest, which is the European Union at 4.7 or 4.8 would be in Japan. So you can see how big our footprint really is, and we'll do an activity with this later if we haven't already to figure out specifically based on your means of life, how many earths or how much land would it take. So let's take a case study, a case study about China. Now China is becoming a new affluent consumer. Now it is the leading consumer of various foods and goods like wheat, rice, and meat, coals, fertilizer, steel, and cement, but it's also the second largest consumer of oil. We always see China as one of those third world nations that doesn't use a lot of resources, but really they use quite a bit of resources to making the products that we actually buy here in the United States. 2/3 of the most polluted cities are actually in China, and they project by 2020 they will actually be the largest consumer and producer of cars and lead the world's economy in terms of GDP and PPP, which you can see they are their average person is going to be more wealthy than anyone's average person in any other country in the world. Cultural changes have also increased our ecological footprints. Just taking a look at this overall, 12,000 years ago we were hunters and gatherers gathering food. We have had 3 major cultural events that really have changed the shape of our population, also our ecological footprints, and that was the agricultural revolution, learning to grow crops better and having a more abundance of those. The industrial medical revolution, which obviously with industry came technology, and with technology came better medicines, and also now the informational globalization revolution with the World Wide Web and cell phones and everything else. Those are our major 3 revolutions that have really changed the shape of our ecological footprints, mostly for the increase. All right, so we're also going to talk about this real briefly because it's really, really short, but what is pollution and what can we do about it? Obviously, with all these different revolutions leads to larger footprints, which leads to more land or dealing with our waste even more. And so let's take a look at some of the pollutions. There's a couple different types here. There's point source pollution, which is literally where you can see the pollution coming out either the air or into the water. It's usually from pipes, a smokestack as an example. That's an easy one to stop. The non-point source pollution is the hardest. Those are like pesticides blown through the air over great distances, condensing down in the form of rain and then affecting an area. That's a little bit harder to stop because you don't know really where it's coming from. There are many types of pollutants. There are biodegradable ones, which actually break down pretty readily in the environment. There's also non-degradable ones that really never break down or take a very, very long time to break down. And we're going to investigate all the unwanted effects of different types of pollutants later this semester. That's a big chunk of our curriculum, but I just wanted to give you a little glimpse at that. All right, so we can clean up pollution or prevent it, and the best option really is to prevent pollution, which is an input pollution control. Before it's inputted in the system, we're going to prevent the pollution from happening in the beginning, being more proactive in thinking about our manufacturing and what we're doing before it actually goes into nature and affects natural resources. The other one is pollution cleanup. This should be always our last-ditch effort. It's an output pollution control where we're dealing with it after the fact that it's already been implemented. It's a lot harder, more time-consuming, and more costly to do pollution cleanup than it is pollution prevention. And that's where we'll pause today. Next time, we're going to be taking a look at why do we have environmental problems in the first place, and what can we do about them. We'll see you guys next time.